Alright, so you would have done this the day before, Friday. Um, this is from the simulation. You would have done this one first, and then this one. So I'll just go over these two real quick because they're very simple, but you need to be aware of them. So which are following are reasons to use computer simulations rather than real world experiments? Experiments in the real world may be expensive. It is, right? So just check that one. Making experiments can be really expensive. Experimenting in the real world is often quick and saves time. That's not right. Um, it's not quick and it does not save time. It takes long. Experimenting with real people is a hassle. Experimenting in the real world is always safe. Not always. There are times where you're trying to experiment with like new medicine and you don't know its risks or side effects. So this is not right. And then experimenting in the real world may be unethical. Yeah, so unethical, right? Like for example, a new medicine, and it affects other people. So these two, and then match the following scenario with the snapcode simulations. So we did this for the flip a coin, and if you go look at your code for flip a coin, we used the one and two, right? So one is heads and two is tails, right? Picking a bingo number. So bingo numbers, they're a lot. So you would go for the largest one and then roll a die. A die has six sides: one, two, three, four, five, and six. So picking a random between one and six. I hope this makes sense. If not, just let me know in the comments and I can explain it further. But yeah. So this is what you should have today. If you don't have this today, then something's going on. But I'm just gonna go over this real quick, and then I'll quickly make another 3 videos on for the next 3 days. Um, you shouldn't know this. Right now that I'm looking at it, I was like a little confused. But I'll just give you an example. So give some examples of data that computers store as bits. Um, you shouldn't know what bits are, but bits are just uh, zeros and ones. Um, yeah, you should learn this during Unit 4. So after your project. So give some examples of data computers that stores bits. So one example is like messages. Messages. Uh, I'm writing with my mouse, so bear with me. You have messages or you have images. Honestly, anything that's in a computer is stored as bits. Um, and explain how computers transmit data files over the internet. So you'll learn this later. But basically, let's say that you have a message right here, and you're sending a meme to your friend over here. So you want to send it to his phone. You want to send him a meme to his phone, right? I don't know, like I don't know what memes are going on right now, but think about it, right? How do you get this from your phone to his phone? Well, what your phone does when you click send is it breaks this into multiple little messages, into multiple. They're called packets. So you could think of these as like little packets. Um, Again, they're called packets. And then these packets, they travel through the internet. So pretend that this right here um, is the internet. So they travel through the internet and they eventually land close to your friend's phone. And your friend's phone picks them up and he the phone gets all these bits, right? And it's like, I mean, all these packets, and it's like, what is this? But the internet has an algorithm in place where it combines all these packets. So these packets contain some information, and they're restored back here as the message that you wanted, and then that goes into your friend's phone. So it gets split into packets, and it travels through the internet, and then when it reaches your friend's phone, it gets those same packets get put back into the message. So there, it's like disassembled and then assembled back on the other end. Again, you learned this in Unit 4, so that's fine. Don't worry about it. So look, where's this? So you have, this is your timeline for Unit 5. We did all these together while I was there. Then you had a video for each one of these. Now we have these 3 left. So I'm gonna try to split them into one video. I mean into 3 videos. From here until, I mean in 2 videos. So today and Tuesday. And then you'll take your assessment. So today we're doing just pages 1 and 2. So we're gonna do this, it says day 12. You have these other 2 for Tuesday. And then I think the plan is to just do a review. I think I have the review. If not, I'll see what I can do. But yeah, we'll do these. So you should have this link right here in this page. And it says, in this page you'll learn how data visualization can help you understand data. Large data sets can be overwhelming to analyze. Okay, so make sure you, in the back of your do now, you're taking notes of this. So whatever I write, would encourage you to write it as well. So data and information. So large data sets. You can write that large data sets are difficult. Why does it keep telling me? Are difficult to analyze. That's something. That's something that you need to kind of get in your head. If you have a lot of information, it gets harder to analyze. Then it says, what software tools can help people extract information, identify trends, make connections, and solve problems with data. Software programs such as the graph below from Google can allow you to process data interactively and gain insight and knowledge. Okay, so this whole page is an activity, but the links are broken. So like there's supposed to be a data set here, so if you click on this, it takes you to the web page. And I've been trying to look for the data set that the activity is looking for, but I can't. I can find it. Like, I don't know which one. Maybe it's like outdated or something. But it's fine. So the activity just asks you to identify some things from a graph, to analyze it, and answer some of these questions. Like there's specific questions, so we can't really do much. Hopefully on your end it works. If it doesn't, then don't worry about it. About answering these questions. But for example, like you would click on, I don't know, health, and then which are the biggest health conditions in Arizona, and you'd find these. So it's better if you click on this link, and it takes you here. So for example, health, which are the leading causes of death in the U.S. No. And you have death from diseases in the circulatory system, and you have this graph, right? So these are different causes. This is how many people die. Yeah, I mean this is information, right? And that's what the lab page in the bottom says. I mean data, right? So make sure you write this down. Data are the values that computers receive from various sources. Um, so we don't know what sources they get their information from, but it's like, um, it's just data. It's numbers, values, and the computer just plots them in a graph, and it's able to like visualize them. Oh, I think it's this one actually. Life expectancy. What does about life expectancy? Oh, okay. I just found it. Oh my god. Um, we won't do the activity though. Don't worry about it. I had already mentalized that we were not gonna do it. I think it's this one. So, what does the interactive dataset tell you about global trends and life expectancy over time? So life expectancy, like it keeps increasing, right? So in 1996, I mean in 1960, it was like 70, and now in 2020, it's like 78, and then you see it lowers down right here to 76. Um, that's because of COVID, right? A lot of young people died during COVID, so the average expectancy went down. Um, yeah, so you'd kind of have to look at these other ones, like fertility, like where do I find that? Um, Move to a cluster, move slide all the way to the left, and describe the meaning of yeah, like I don't know what these are. At least we find something, right? But yeah, so you get these numbers, you get these visualizations. For example, uh, you get all these lines, and you're like, what do they mean? Um, and for example, that life expectancy one, like, what does this dip right here mean? Why does it lower? Or I saw this one right here. Like, why does the line go like this? Like, what does this mean, right? That's the information. So, information, information. This means like, what can you extract from the data? What sense can you make out of what you see? So, the humanly useful patterns extracted from data. That's what information is. So you look at patterns. What does it tell you? So right here we know that it's talking about the number of deaths. So we know that they're increasing, 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 and then this change, it tells us it increased a lot. And you see here it's 2020. So it's COVID. And then it decreased after the vaccines, right? So data provide opportunities for identifying trends. And then information is the result of analyzing that data. So a computer gets its data, and then a person or some code is able to identify patterns and say like, oh, the deaths here happened because of COVID, or during COVID the deaths increased, something like that, you know. And then you have another vocabulary word, which is very important, and it's called correlation. Um, I don't know if you've seen this before. I don't think so in your math class, but it's um, a dependence between two variables in a situation. A dependence, a dependence between two variables in a situation. In a situation. All this means is that one thing stems from another thing. So for example, in the first picture here, as one variable goes up, so as the x-axis increases, the other one goes down. So you see all these points are getting lower and lower as you get to the right. This one, as you go to the right, the points go higher and higher and higher. And then this one, it has no correlation. So again, draw these right here. So you have 3 different ones. And then you can have, this is a positive correlation. If you have the information going this way, then that's negative. But then, and then if you have it just scattered everywhere, then that means there's no correlation. So you have they're like trends. Like, is it going down? Then that's negative. Is it going up? Then that's positive. If you see no direction, then that means there's no correlation. An example, and these are funny examples. So this is a website. I think if you click on here, it takes you to this website. Yeah, just like delete that part of the link. It's about this website, and for example, it's like 2 variables, right? Or 2 different things that have similar correlations. So the consumption of margarine, I don't know what that means. I think it's like something for your pizza. The divorce rate in Maine, and they have the exact same correlation. Like, it's just funny. And I think if you click on this, it gives you more. So the number of movies Margaret Robbie appeared in, and the number of firefighters in South Dakota. And for some reason, they have a very similar correlation, right? So it goes up right here, then down, then up, then down, then up, then down, then down. Yeah, it's like a dependence on 2 things. So right now, here it depends on movie appearances and firefighters, and they have just like very similar. Next page, bachelor degrees in mathematics, and then a stock price, and they have the exact same. Would this be positive or negative? It's going up, right? So it's positive. Master degrees awarded in liberal arts, popularity to success kid meme. For some reason, they have the exact same correlation, or similar. Yeah. I mean, you could say that this meme caused less people to major in liberal arts or something. I don't know. I mean, that's not. You need more research to back it up, but still. And then another vocabulary word. I'll just put the side right here. You have it as insight. All this means is a meaningful conclusion drawn from analyzing information. So going back to the example right here, so we analyze this information and we see it go up, and we look at how it correlates, right? So it's the time is 2019 and 2020, and it jumps from 2.5 to 3 million. And we're looking at number of deaths, right? So we see that there's a very positive correlation here, a very big increase. We analyze it, right? That's this part right here, analyzing. And now our conclusion is, oh, a lot of people died because of COVID, because of the pandemic. So that's the insight from this information. Mm. Next. So now in this page, take your time with these questions. So these are questions you'll see in the AP exam. And you need to use a lot of like context clues and common sense. So these are freebie questions, really. If you read the question, if you internalize the information, you have to analyze it and then make a meaningful conclusion out of it. Um, but it's very easy. You cannot get these wrong. And if you do, it's okay. But just make sure you pay attention, read along the line, read between the lines. These are questions that require just a lot of common sense. So pause the video, and then take some time to answer these. Don't guess on them. Don't guess on them. Really read the question and analyze them, and then answer them. Okay? So pause the video, and then I'll just go over the answers. Okay. So these are questions similar to those you'll see on the AP exam. So the question says, scientists are studying birds often. Scientists studying birds often attach tracking tags to migrating birds. For each bird, the following data is collected regularly at frequent. So you have date and time, latitude and longitude. This is the location. Altitude, so how high they're flying, and temperature. Which of following questions about a particular bird could not be answered using only data gathered from the tracking tags? So we have this information. There's a lot of insight we can get from this information or from this data, right? There's a lot of information we could gather. So let's see. Let's look at it. What are the effects of industrial pollution on the migration path of the bird? So will we know the path of the bird? We will, right? Because we'll know its location, its latitude and longitude. And we know industrial pollution from other places, maybe the temperature. So this maybe, because we don't really know the industrial pollution, right? We can't just measure it from these things. We will know the path, but we don't know the industrial pollution of that specific path. So is the migration path of the bird affected by the temperature patterns? So again, we know the path and we know the temperature. So this one we know for sure. So this is not our answer. So because this one is a yes, right? And we're looking for the cannot be answered. We can answer this one because we know the path and we know the temperature. Does the bird travel in groups tracked with other tracked birds? So are there any other birds there? We know the location and the date and time of every bird that we track. So we do know the location of other tracked birds. So this one would also be a yes. Approximately how much time does the bird spend in the air and on the ground? So we know its altitude, so we know if it's in the air or in the ground, and we know their time. So we are able to track their altitude and how long. So this is a yes as well. So the only one is this one. And again, we know their path, but we don't know the industrial pollution from just from this information. So check. There is no data collected on pollution in the bird's environment. Yeah. So we don't know industrial pollution. We know the path, but we don't know the pollution. Using computers, researchers often search large data sets to find interesting patterns in data. Which of following is not an example where searching for patterns is needed to gather information? So we're looking for not an example where searching for patterns is needed for design information. So we're looking for a specific information that patterns are not useful for. So let's look at the answers. A college analyzing high school students' GPA and SAT scores to assess their potential college success. So the pattern, if they get high GPA and high SAT scores, they will probably do well in college, right? That's common sense. So this one is probably an example of patterns for college success, right? Good GPA, good scores, college success. That's a pattern. A credit scoring company analyzing purchase history of clients to identify cases of identity theft. Um, this one's tricky because you may not know what purchase history means or identity theft. Um, but let's pretend that you buy a lot of, um, I don't know, you buy a lot of stuff from Amazon, um, and then out of nowhere, um, someone steals your card, and they keep buying stuff from Amazon. Um, your purchase history will say, "Oh, this guy purchases a lot of stuff from Amazon, so it's probably them." But maybe, but like it's someone with identity theft, you know. So these patterns. Um, but now let's say you don't buy a lot of stuff from Amazon, and out of nowhere, you get charged like 2,000 on Amazon stuff. Then the patterns will be like, oh, this guy doesn't buy anything from Amazon, but he bought just $2,000. Like there's something fishy. So the pattern of your purchase history to check identity theft. That's that's an example of using patterns for desired information. An online shopping company analyzing customers' purchase history to recommend new products. Again, your purchase history for new products. Like if you're buying a lot of shoes, you get recommended more shoes. If you're buying a lot of makeup, you get recommended more makeup. So it's patterns to analyze to get desired information. Um, and then a high school student analyzing attendance records to determine which student should receive a disciplinary warning. This is tricky. I would go for this one. It's probably wrong. Let's see. Because, well, it depends what disciplinary means, right? Because attendance wouldn't require disciplinary action. It would be more just like correcting. I would go for this question. It's either this one. I think it's just this one. Check answer. Yeah. So there's no need for pattern analysis, just sorting the data to get the list of students with poor attendance records. So you don't need a pattern. That's what this means. So you just check who has the highest amount of, or like you just sort the attendance, and let's say that the cap is 10 misses. So if you have 10 absences, you get a warning. That's not a pattern. Um, a pattern would be something like the increasing absences. So you check for the attendance records to determine which school is the most affected, has the most decrease in scores, or something like that, where a pattern of increasing absences leads to lower scores. That would be patterns. So I'll just go pretty fast because I'm almost at 30. So a car hailing company is an app that travels. The data collected can be filtered and sorted by geographic location, time and date, miles traveled, and the fare charge for a trip. Which of the following is least likely to be answerable using only the trends feature? So we're looking at geographic location, time, date, miles traveled, and the the charge. So least likely to be answerable. What is the time of the day? Is the busiest for the company at a given city? So we know the time of day, we know the location, so we know the day and the city. And we also know the busiest because we know the fare. No, we wouldn't know the busiest. Oh no, we would. Okay, that's a maybe. So we know the time of day, we know the given city, but we don't know if it's the busiest. That's a maybe. Okay, how is competition with the local cab companies affecting business in the given district? Yeah, because we know the charge, we know the locations, so we know the district, we know where they are, and we know how much they're making. So I think that's a yes. The only thing is competition, so we don't know competition, so that's also maybe. From which geographical location do the longest flights originate? Yes, so we know the miles traveled and the location, so that's a yes for sure. So this is not our answer. How much money was earned by the company in a given month? We know the fare. So a car had used the app to track travel transfer. So we do know how much it was. Well, we don't know all the money. Maybe that's the answer. Because we don't know, like, as a whole. We just know how much it charged for each trip, but we don't know how much it made. I think that's the answer. Oh, okay. That's vague. But yeah. So we do know how much they made. So they're talking about these, just how much they made throughout the month on this. Um, so so it's not this one. Okay, so it's not this one, it's not this one. Last competition with local cab. What time of day is the busiest? I would say this one because of competition. Let's guess. Yeah. There's no information on the competition. Yeah. So we would be able to figure out where the busiest time is by just looking at time and date and the miles and the location. But we don't know the competition. An online music download company stores information about the song every day. The following information is made publicly available to the company's website. So the day and date of each song, the title, the cities, and the number of time each song was purchased. An example portion of the database is shown below. So you get an image of the information stored in the database. Which of the following cannot be determined using only the information in the database. So again, we have this information, which one cannot be determined. So the total number of songs purchased by a particular customer during the course of a given year. So we know how many songs were purchased. We wouldn't know by a particular customer. There's no identifiers here for a customer. We know how many times they were purchased, but not who who made it. The total number of cities in which a certain song was purchased in a given month. Yeah, we would just check which song it is and then count how many different cities. So this one's yes. The city with the fewest purchases in a particular day. Again, we search by day. Right, we'll look at, I don't know, this Monday. So which one had the fewest? It would be city with the fewest purchases. Particularly, it would be Chicago, right? That's the city with the fewest purchases. And then the song that is purchased the most in a given week. Again, you would sort within a week and just look at which song was, or add up the ones with the same song and check. So yeah, I think it's the first one because there's no particular customer data. Correct. There's no data for the individual customers. Yep. So take a screenshot of this and turn it into your assignment, or just attach them and save them as draft because you still work. We'll do these two tomorrow. This one's not project. It looks fun. But yeah. Answer your exit ticket right here. You have the vocabulary.